Good day students. So today in this presentation we are going to see the secondary storage systems in operating system. So before we jump into the presentation, we need to understand why do we need secondary storage systems. So basically we want programs and data to reside in main memory permanently. This arrangement is usually not possible because of two reasons. Main memory is usually too small to store all needed programs and data permanently. And the second reason is that it is volatile storage device that loses its content when the power is turned off or otherwise lost. So because of this, there are two types of storage devices. Volatile storage uh, devices and non-volatile storage devices. Volatile storage devices it loses its content when the power of the device is removed. Non-volatile storage devices, it does not lose its content when the power is removed. It holds all the data when the power is removed. So secondary storage is used for an extension of main memory. Secondary storage devices can hold the data permanently. So storage devices consist of many things. Few are given in this presentation, which are floppy disk, hard disk, magnetic tapes, and we also have disk structure and disk scheduling. But here we're going to, in this presentation, we're going to only focus on secondary storage structures or the systems or devices which are floppy disk, hard disk, and magnetic tapes. So by a hierarchy, you can see that's how it behaves. So the magnetic device or the magnetic disk provides a bulk of storage um, to the modern computers. It's a secondary storage devices. It drives rotate like 60 to 200 times per second. Transfer data is that the data flow between the drive and the computer is very important. Position time, which is your random access time, is important, and the seek time. So how do you desire, how do you get information? And the rotational latency is also very important. Head crash is also important because the disk surface is, whether it's smooth or it's bad, it's upside down. So these are all very important. Disk can be removed. Drive attached to the computer via input and output buses. Buses vary include EID, ATA, UBS, USB, I'm sorry, USB, fiber channels, and so on. So this is an example of a moving head disk mechanism. As you can see, the arm assembly is to hold the arms. So the black part of the arm will be called as read slash head, the right head. So if the user is reading, the head is considered to be read head. If it is writing, it is write head. So we have the rotation mechanism done by the spindle, and we have track T, sectors S, cylinder C, and platter. Platter is nothing but the entire disk. Cylinder is nothing but, can you see the dotted lines? So this dotted line is considered to be cylinder C, and each cylinder has a section S. So as you can see, the blue thing is divided into multiple sections, and the tracks, so it will look like a track one after the other. So by this only the informations are read and read and also written. Disk structure. So disk drives are addressed as large one-dimensional array of logical blocks, where the logical blocks is the smallest unit to transfer. The one-dimensional array of logical blocks is mapped into sectors of the disk sequentially. So by this disk structure, and we have magnetic tapes. So these this is an example of a magnetic tape. As you can see, You have a tape reel. So once it goes clockwise, um, so it goes in an anti-clockwise, so that one reel is let go, one reel is collecting all the reels. You have a read write head where the tape goes. So if it is reading, you the head turns into read head. If it is writing, it turns into write head. So this is how your magnetic tape works. And the next is disk scheduling. I will just give the introduction of disk scheduling and not go into details. So disk scheduling algorithms are nothing but first come first serve, shortest seek time first, scan, circular scan. You also call it as C scan, look and see look. So we have two things very important: seek time and rotational latency. With a disk bandwidth, the total number of bytes transferred is understood, and you also have RPM, which is rotations per minute. So with this, I conclude my presentation. Meet you in another presentation. Thank you.